Would before we do today's, would any of you guys like me to go over any of the homework problems you had yesterday that maybe weren't making sense or anything? Because today's is a lot like it. So if you had some troubles with yesterday, wouldn't be a terrible idea if I, helped you go over some of them. Oh, all right. This is why attendance is annoying. Here we go. Okay. All right. Well then we're going to continue 7-3. So, if I remember correctly, off the top of my head here, at the end of 7-3, what we did was we learned how to, look at that where I wrote reminder. So at the end of 7-3, we were learning how to put together bases when they're multiplied, and you add their powers. And today is just kind of building off that, to be honest. It's just learning the rest of the properties. So that's kind of why I asked how yesterday went for you, because it's probably going to feel a lot like the same. And as a reminder, so yesterday's and today's work was kind of meant as like our 4-day weekend amount of work, so that we don't fall behind and have to rush like crazy later on. So your goal is by Tuesday, because we don't have, I said that wrong, we don't have school Monday and Tuesday. So your goal is by Wednesday to be able to have the homework done from 7-1, 7-3, and 7-4. And that's what I said. I was surprised how many people actually did that yesterday, and that was good. So up top where it says reminder, that's what we did yesterday. Today is, what's the best way for me to say this? Each one of these properties we learn is like easy on their own. But it's really easy to get them mixed up once we start combining them all, right? So today's is when you have a power to a power. So like this one, I've got 7 to the 4th to the 3rd power. Now what I wrote in white is what it means. 3rd power means that you're multiplying 3 of the same things. So if I took the time to write it out the long way, I could just add the powers and get 12. Well, this is the same thing as saying 4 times 3. So what I wrote in blue is the actual property. If you have a power to a power, like 7 to the 4th to the 3rd, you can multiply their powers. So you get 7 to the 12th. And maybe this is where you guys can see why it might start to get confusing. And I fully get it. When you're multiplying bases, you add their powers. When you're powering bases, you multiply them. So once we start combining things, it definitely gets weird and easy to mix them up. So that's why we're going to kind of purposely try to do a bunch that are similar to start with, and then as we work, we start combining. I will help you off on the first example here down below. 3 to the 6th to the 2nd power. Because it's a power to a power, we're going to multiply those two powers. So you get 3 to the 12th. Now this was kind of where a handful of people were asking questions yesterday, right? So wanting to know if you're supposed to figure out what 3 to the 12th is. And the answer is no. Because the whole purpose of this, these properties, these rules and everything, is to learn the properties behind them. So by you writing 3 to the 12th, that's me being able to figure out that you know the property. I could care less what 3 to the 12 is actually equal to. I mean, that's not something I'm going to do in my head. So I'd be like you, where I would just put it in a calculator. Let's go with some volunteers like Logan. Wait, Logan, I think I called on you first yesterday. Oh, you know, I'm going to erase the answer that you saw. If I was trying to use the property, what would I do? Because I've got a power to a power. Oh, wait, Logan, I know I heard you say something, but before, were you trying to say that I did call on you first yesterday? You're kidding me. Oh, you could have yelled at me for that one. Well, that's my fault. You're exempt from today totally then, Logan. How's that? Alex, we need somebody to take up Logan's slack. He decided that he wants to take today off. Do you think you could help me know what to do with this one? Thank you. Perfect. Excellent. So I would have accepted 2 to the 0. What were you going to say? Yeah, absolutely. And honestly, if you guys would have seen it from the start, if you would have noticed right away that we had something to the 0 power, we absolutely could have just written the answer was 1 to start with, because anything to the 0 power is 1. And I would have been okay if you noticed that. Nice job, Alex. Gracie? Any thoughts on the green one? Because I've got some extra stuff there. Okay. Do you want me to kind of go through it with you? I will definitely do that. So what I would do is kind of like PEMDAS. When I see a parentheses, I would ignore that part to start with. And I would focus, okay, I apparently wrote this badly. I would try to figure out what x squared to the -4th is first. So if we have a power to a power, what do we do with those again? Okay, perfect. What do I get out of that? Okay, excellent. And now so this times x to the 5th, I'm going to keep writing it at the end. What do I do now that near the end I'm multiplying two of the same bases? Do you remember what to do with the powers on that one? Nope. No, that's okay. That's why I kind of picked this problem as an example. So if I scroll back up, yesterday, when you multiply same bases, you add their powers. And this is definitely why this can get confusing, why I picked this question. So if you've got a power on a power, I keep saying power. If you have an exponent on an exponent, then you multiply them. If you've got two of the same bases, then you add them. It would. And then do you remember from yesterday what we do? Because we're not supposed to write final answers with negative or 0 power. Do you remember what I do with that negative power? That's okay if you want me to pass it off to somebody else, because you've answered a lot here. Okay, I can definitely do that. That's all right. Ben, how about you? What do I do when I have a negative power? How do I write the final answer if I have a negative power? Because final answers aren't supposed to have negative powers. Green, what I just underlined. Yeah, we do. What would I write it as? So the negative symbol means 1 over. And then what do I write on the bottom of the fraction? X to the third, but yes, if that's what you meant by 3. Yeah, it becomes a positive 1 on the bottom. Good. Good. This one absolutely had a lot of rolls in it. And this is 100% why each individual thing we learn is not bad, but once you start combining them together, you definitely have to keep it straight. Anybody want to volunteer for the yellow one? I don't know if this one would feel difficult to you or not. Does anybody have a thought what we're going to do if we have more than one item? Sophie? And even if your mic's not working, you could type it in the chat or something if you want. Do you know what we would do when we have a cube down here? Oh. Perfect. Perfect. So if we have more than one thing on the inside, you're going to kind of apply the cube down to both. So we've got x squared times 3, y fourth times 3, because it's like an exponent to an exponent on both. Nice job. And then these are different letters, so we can't put them together. So this would be your final answer. Now this is the rest of 7-3. And those of you who did the homework yesterday, you probably saw that the homework questions go really fast for this section because you kind of just do the powers, and the numbers aren't usually that big, so you can kind of do them in your head. Does anybody want me to talk about any one of these? And I don't know, I tried to put them in different colors so you could reference the colors if you needed to, but okay. So here's the next property. And you might have been able to figure it out on your own ahead of time. What I wrote in white is why it works. The white you don't have to do, okay? What I wrote in blue is the actual property. So if you have two of the same bases being divided, you can subtract them. And then you do top minus bottom. So it's just like when they're being multiplied, you would add their powers. If they're being divided, you take them away. I mean, kind of like an opposite operation, you do the opposite thing. But what I wrote in white is how come it works. And it's okay if you don't know how to do that, or, like nobody would do it because it takes forever. So if I have 3 to the 5th divided by 3 squared, I'm going to take a single 3 and then write it as the top number minus the bottom number. Now, I'm saying that very specific because, sometimes numbers can be negative, but it's always the top minus the bottom. And if, I guess I wrote this over on the side in the note. Once you subtract the powers, the answer goes on the top. And you'll see why I wrote that. Once we start doing problems right below, you can kind of get a preview of them a little bit. There, I'll leave the note with the actual property up there while we work on these. And for these, we don't want an actual number answer unless it's super easy. We just want to figure out the power stuff. So when I'm there we go. When I'm looking at 4 to the 8th divided by 4 squared, well, they're being divided. They're the same base. So I'm going to put them together and then take top minus bottom. So I'd have 4 to the 6th. The one with the 7s is where I started mentioning that, you know, it's always top minus bottom no matter what. So if I have 7 to the 5th divided by 7 to the negative 3rd, I'll take the top power minus the bottom power. And then when you subtract a negative, I don't know how you guys learned it originally. Did you guys learn chop, chop, slash or something like that? I know that's how I'd never learned that when I was younger. But I hear of a lot of people that learn it that way now. Basically, 2 negative signs together make a plus. So this becomes 7 to the 8th. Now, usually at this point is when somebody asks me about this. So if I decided to do this problem differently, I could, and I would still get the same correct answer at the end. So if I wanted to, I could have decided to bring this up to the top as 7 positive 3. Because remember, a negative power moves it. If I would have brought it up to the top, then it would be multiplied, so I would add their powers. Still get 7 to the 8th. Basically, as long as you use your properties correctly, you can kind of choose to do them in whatever order you want, and you should have the correct answer when you're done. Like if you decided to just leave it as division and subtract the powers, you get 7 to the 8th. If you would have decided to move that to the top to make it a positive power, you could have added them and got 7 to the 8th. So you definitely will find that for quite a few of these problems, you might do it slightly different than I do, but generally, if you do it correct, you'll have the same answer, right? And I know it's possible to get the correct answer on accident. That just doesn't happen often. Isabella, what do you think about the one in white? Any thoughts as to what we should do when we have a bunch of things? Good. Good. Yep. 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 2 minus 4. Yep. Perfect. Perfect. So I'll do this, and I'll get 2 squared, 3 negative 2, 5, 2. Haroon. Haroon, normally this would be done, and this would be our final answer. But I see on the 3, I have a negative 2 power. So what do I do with that negative 2 power in the final answer? Perfect. I didn't hear the rest of it, but that's okay. What the part I heard you said was perfect. You said to make this 1 over 3 squared. But because these are all together, what I'm actually going to do, instead of having a 1 on the top of the fraction is going to have these other 2 things. And then the bottom would have 3 positive 2. So it still works the same way. You're essentially moving it to the bottom of a fraction. But because we had other things there, they stay where they were. Desmond? What about the one in red? Do you think you could help guide me a little bit? Okay, okay. I can help you out if you want help. Did you say by 2? Wait, are you talking about the red one or yellow one? Okay, that's why I was wondering where you got 2 from. Okay. What do I... Yeah. Perfect. And these are both technically a first power. So you do multiply them. Yep, you do multiply them, but it still multiplies into a 4. Okay, good. Good first step. All right. Any thoughts? So what I will say on this question is you kind of said it perfectly that I have to do this parentheses first because the A and the B are kind of like joined together, so I couldn't do anything with the top until they're separated. Good. So A to the first, or I could just leave it blank, B to the fifth. Nice. Very nice. Why don't you guys try to do the one in yellow on your own, if you haven't already? Try to do the one in yellow on your own. See, so that one's got a bunch of things in it. Okay. If you're not done, that's okay. I kind of figured I'll just get going because if you're stuck, then you can kind of watch. First thing you really need to do is take care of parentheses to start with. So like the top would stay alone. The bottom, the n, nothing would happen to it. But this m to the fifth to the second power would become m10 when you multiply the two of them. And then at this stage, since there's no parentheses, I can kind of combine tops and bottoms. So I would do m5 minus 10, n, and again, when there's no number, that's like a 1. So n4 minus 1. So this one had a couple things that would be easy to miss. And then this would be done, except we have a power that's negative in the final answer. So this negative would go to the bottom. And you would have n3 on top, m positive 5 on bottom. Now, if you were able to get that on your own, that's pretty awesome. That's very good. And I'm going to guess today is partially going by a little bit quicker because it's similar to yesterday, so you kind of are in the mindset for these exponent problems already. Anybody want me to help them on maybe they did something wrong on the yellow one and they don't know why? Like didn't end up with the same final answer, just can't figure out how come? Okay. Then we're actually moving on to the last part of our notes already. And this isn't really like a separate section. It's just that it's good to have these fraction ones in here because a lot of students get really confused on the way they're set up. So if you have a fraction with a power, the power goes on both the top and bottom separate. Like that's not a big deal. That's kind of like what we did up above. But the part that's really weird is if you have a fraction to a negative power, instead of doing 1 over, because 1 over a fraction is like generally worse, right? what you can do is just flip the fraction upside down. So if I had 5/6 to the negative 2 power, I most definitely can write it as 6/5 to the positive 2 power. And that's generally really helpful because then it kind of keeps the problem looking cleaner and easier to follow. You can write 1 over a fraction. It's just that most people are going to get really messed up when you do that. So it's just not usually recommended. Okay. Let me erase my 2 in this green problem because I bet you some of you think it's a z. I usually write my 2's that they look exactly like a z. So as I was going through schooling, I found that I had to start writing a line through my z because I couldn't tell the difference between a 2 and a z in my own handwriting. So if you're ever unsure, just ask, but I try to make them different. All right, green one. What do you think, Sadie? Any thoughts on the green one? Okay. Do you want me to kind of guide you through it? Okay. So when I'm looking at this, I see a parentheses with a third power on it. First step, excuse me. First step is to take this third power and put it, like apply it on everything on the inside. So do you think you could tell me what to write once I put the third power on everything? Okay. Good? Perfect. Perfect. That was kind of the one thing in there to think about for sure. Perfect. Good. Yeah, good. Very good. If you decided to write 2 to the third power as 8, I'd be okay with that because 2 to the third is generally something you can do in your head. I'll just leave it like this. And then Sadie, lastly, can I put any of this together? Like, can I combine anything? Okay, you are correct. The reason I can't combine anything is because their bases are all different. If they had the same base, we could put them together. Nice. So this one's correct. Or if it bothered you, you could write 8x9 over y cubed z cubed. Good. Murph. No, I called on you probably a couple times yesterday too. Okay, Mason, I'm going to call on you, but I know your microphone goes like screamingly loud for whatever reason. It might be easier for you to type in the chat. Do you know what I should do with the pink one? And you don't have to write the number answer, just maybe tell me what to do. Maybe. Maybe you're writing out a really long answer, Mason? Or maybe you didn't hear it was for you? Okay. Caroline, how about you? I don't know if Mason's there. There's a couple different things we could do. As long as we have the same correct answer, we're fine. What would you do? The pinkish, I don't even know what color that is, to be honest. The middle one. I could. That is definitely something I could do to start with. This is why I was saying there's more than one way to do a lot of these, so whatever you want to do is fine. Okay, so I did that. And then what would I do lastly? So we can't write a final answer with negative powers. Do you remember what you do with negative powers to make them positive? Oh, okay. So if you have a negative power, you can move it to the other half to make it turn positive. So then this would be 5 cubed over 2 cubed. So whenever you have a negative power, you can move it to the other part to make it be positive. Okay, now that was the way Caroline wanted to approach it, and there's nothing wrong with that. There was another way to do this same problem. Oh, that's all right, Mason. That's not a problem. Yeah, I did. I was calling in you, but that's okay. That's basically why I record these, because technology can just go bad at any moment, and sometimes there's nothing you can do about it. And so I'm not going to blame anybody for your technology issues. It's like when we have our staff meetings, and for some reason, they always want to play videos in the staff meetings while they're trying to stream it. And every single time it doesn't work. And then everybody always acts surprised when it doesn't work. But it never works. Let's see, who should we go with? We need an ace here. Who should I call on? I don't know who I haven't called on yet. Sophie? No, I called on you. I don't know, this class is so small, it's hard to remember. AJ? Do you remember what else we can do when we have a fraction to a negative power? Yes. Yeah, perfect. If you have a fraction to a negative power, you can flip the fraction upside down and write a positive power on it. And then, say it again, for the first one? No. Oh, yeah, you get the same answer either way. Absolutely. I was basically just trying to show that you can do it 2 different ways. So when you guys are doing these problems, whichever way sticks out to you in your brain, do that way. It works. Because sometimes one way seems easier to you than another. Here's what I would like you guys to try. This is going to be our last problem today. This has a lot of different things in it. Why don't you guys try the yellow one to see if you can get the final answer? I'll give you a couple minutes for it. The yellow one has a bunch of things going on. Excuse me. This one is actually a really good example of why flipping the fraction upside down can be helpful. Because if I put this -1 power on both of those, and if I put this -2 power on all of those, that's a lot of negative powers to be working with. And it feels really confusing to do that. So sometimes sometimes one way will work out a lot easier than others. And so that's why it's kind of handy to be able to see different methods. I would definitely start with flipping both fractions upside down and putting positive powers. And like this first one, when I have a first power, honestly, you don't even have to write to the first power. I'll just say 4/3 times, and then I'm going to square everything in the second parentheses. Now this question feels a little bit different than the other ones we've done because it's actually a lot of numbers. And so we might want to try to like cancel or simplify them if we can. So the top of my fraction is 4 times 9 y squared. Because when you're multiplying fractions, it's all like one big fraction. The bottom of the fraction is 3 times 4 times x. Now, if you want to write this as 36 and 12, you can. Otherwise, I'm going to cancel and reduce. Like 4 divided by 4 reduces. 9 divided by 3 reduces. And then together they're all a 3 on the top. So my final answer would be 3y squared over x. And it seems kind of weird that the really big problem to start with actually boils down to very little left. And I'm pretty sure that was the end of the notes. Oh, I just had some other examples, but no need to. I don't want to run you guys too far into the class hour. We only have 15 minutes left, 15, 20 minutes left. And I definitely want to give you a little bit of time to work. Some of you guys, I think, feel like you know this pretty well, and others of you, I think, it's getting confusing. So absolutely try practicing it, because that's going to be the best way to figure things out. And don't forget that, you know, I'm on from 1:15 to 2:30 every day if you want help with something. I'd gladly help you. Otherwise, I guess I'm done today for notes. Thank you guys for coming. You have a super long weekend. And in fact, you only have 2 days of school next week. So just try to get this homework done by Wednesday. See you guys later. You're welcome.